Have you seen the McMurtry Spéirling? That
No.
thing that got the Goodwood record? It's a
No.
vacuum car. It's a fan car. So it's I was there at Goodwood when it did its legendary run. I think it's got the fastest record going up Goodwood.
We've all heard the myth. A Formula One car can drive upside down. It was a fun idea, something you joked about in physics class, but no one ever actually did it. Until now, because McMurtry just took that urban legend and slammed it onto a rotating steel platform literally and drove their 1,000 horsepower electric hypercar upside down.
So here I am in the McMurtry Spéirling. So we're going to do our very best to demonstrate just how powerful the downforce technology is on this car.
This isn't CGI. This isn't a publicity stunt. This is physics turned performance, and it's flipping the entire automotive world on its head. Literally, if you thought racing tech was peaking, think again. The car that broke physics. For decades, motorsport fans have passed around the same thought experiment. What if a Formula One car had so much downforce that it could drive upside down on a tunnel's ceiling? It was the stuff of barstool physics debates, coffee-fueled engineering classes, and YouTube theory videos that racked up millions of views. But it always stopped at one key problem. Nobody ever proved it until McMurtry. Because while Formula One cars technically generate enough downforce at high speeds to theoretically grip the ceiling of a tunnel, nobody has ever done it. Not because it was impossible, but because no one was crazy enough, bold enough, or innovative enough to build a car that could make it happen without relying on sheer velocity alone. That is where the McMurtry Spéirling changes the story. It is not a Formula One car. It is something far more terrifying. A 1,000 horsepower electric hypercar that weighs just under 1,000 kilograms. And instead of waiting for airspeed to push it into the tarmac, it uses a fan system to generate downforce at 0 miles per hour. No long straights, no wind tunnels, no magic, just engineering that bends the laws of driving as we know them. The McMurtry Spéirling does not just accelerate like a bullet, it sticks to the road like it is afraid of leaving it. With the push of a button, its fan system can create 2,000 kilograms of downforce on demand. That is more than the weight of the entire car itself, which means this machine does not need speed to create grip. It creates grip before it even moves. And that one feature changes everything, because if you do not need speed to generate downforce, you do not need a racetrack to prove the theory. You can build your own gravity-defying test rig and let the fans do the work. That is exactly what McMurtry did. They built a rotating platform that could tilt a car until it was completely upside down. Then they drove the Spéirling onto it, activated the fans, locked the platform in place, and watched it hang in the air like a spaceship testing artificial gravity. But that was not the end of it. Once fully inverted, company co-founder Thomas Yates calmly rolled the Spéirling forward, unsupported, while completely upside down. He did not spin the wheels or hit a ramp. He simply pressed forward and let the vacuum underneath him do the rest. It was quiet, controlled, effortless, and utterly mind-melting. Because for the first time in automotive history, a car did not just generate enough downforce to theoretically stick to the ceiling, it actually did it. Now, to understand just how insane this is, you have to know how typical race cars work. In Formula One, downforce comes from wings and airflow. The faster you go, the more air is pushed over and under the body, generating vertical pressure that keeps the tires glued to the ground. The problem is, it only works when you're already going fast. It is like a parachute in reverse. Without speed, it is useless. So even if an F1 car could drive upside down, it would have to hit speeds of around 180 miles per hour and maintain them consistently. And it would need a tunnel designed to accommodate that speed safely, which does not exist. It has never been attempted, and probably never will be. But McMurtry bypassed that entire limitation by inventing something completely new. Their downforce on demand system is not a marketing gimmick. It uses twin fans spinning at 23,000 revolutions per minute to suck the car to the surface beneath it, no matter its orientation. That means the car sticks, whether it is climbing a wall, sitting still, or driving across the ceiling of a metal rig in the British countryside. This leads to a new question. If Formula One cars can't do this, and McMurtry can, does that make the Spéirling the only car in history to actually drive upside down? Yes, and not just in theory, which means we now have an answer to a question that has lingered for decades. What car can actually drive upside down? The answer is not a Red Bull RB19 or a Ferrari SF24. It is a stubby, fan-assisted electric monster that looks like it came from a video game and sounds like a hairdryer on steroids. So no, it is not a Formula One car, and that is exactly why it worked. McMurtry took a myth and made it real. They built the world's first upside-down capable car, and then did the one thing no other team has dared to do. They proved it, and they are not finished yet, because the test rig was just the beginning. They are already teasing the next step, a longer platform, a purpose-built tunnel, maybe even a full loop. But before we fantasize about driving on ceilings and lunar tracks, we need to answer the next question. How does this car even work? What makes the Spéirling so uniquely terrifying? Inside the machine, how the Spéirling defies gravity. To understand how the McMurtry Spéirling can do what no Formula One car has ever done, you need to look beneath the carbon fiber shell, because this is not just another electric hypercar. It is a science experiment in motion, a machine built around one principle that has never been executed at this scale. Permanent downforce, generated without speed, controlled with a single switch. At the heart of this madness is McMurtry's proprietary fan system. While most race cars use wings and diffusers to manipulate air as it flows over the body, the Spéirling flips that logic upside down. Literally, it sucks the car downward using fans mounted in the rear, pulling air from underneath the chassis and creating an immense pressure differential. The result is not aerodynamic grip, it is mechanical suction. These twin electric turbines spin at over 23,000 revolutions per minute. Together, they produce up to 4,400 pounds of vertical downforce. That is more than twice the weight of the entire vehicle. Even at 0 miles per hour, the Spéirling clings to the ground as if gravity itself has been amplified. There is no need to wait for airflow. There is no reliance on motion. The grip is instant. This is what allowed McMurtry to perform the upside-down stunt. Traditional race cars would need to be moving fast enough to maintain airflow across their wings, but the Spéirling's fans are always on when needed, and they generate the same level of force while stationary, which means the car does not care if it is on a racetrack, a wall, or the ceiling of a rotating steel rig. It simply sticks. The powertrain is equally absurd. The Spéirling uses a dual-motor electric setup producing roughly 1,000 horsepower. It delivers that power directly to the rear wheels, launching the car from 0 to 60 miles per hour in less than 2 seconds. It is nearly silent, deceptively small, and designed to do one thing better than anything else in its class: accelerate faster and corner harder than physics says it should. But it is not just the acceleration that shocks people. It is the cornering. At Goodwood, in 2022, former Formula One driver Max Chilton used the fan-assisted downforce system to carve through the famous hill climb course in 39.08 seconds. That lap time shattered the previous record by more than 2 full seconds. In racing, 2 seconds is not a win. It is domination, and that is the difference. The Spéirling does not play by the rules because it was not designed for a rulebook. It was built to test the limits of engineering itself. McMurtry stripped away every compromise. There are no mirrors, no excess bodywork, no concessions to comfort. It is a single-seater with the footprint of a go-kart and the thrust of a jet engine. Everything on it exists to serve performance. Even the name has meaning. Spéirling is an Irish word that translates roughly to thunderstorm. It is fitting. The car does not rumble like a combustion engine. It screams like compressed wind. And once the fans are engaged, it becomes something else entirely. It becomes a magnet, one that grips the road with the force of a hydraulic press and refuses to let go. And here is where it gets even more interesting. Because the Spéirling is not just a one-off stunt car, McMurtry is building a production model. They are calling it the Spéirling Pure, and only 100 units will be made. Each one will be track legal. Each one will have the fan system, and each one will have the capability to perform feats that no other road-legal vehicle has ever come close to attempting. This raises an obvious question. Why has no one else done this before? The answer is not lack of imagination. It is technical complexity. Most motorsport series ban fan-assisted downforce. Formula One tried it once in the 70s, and it was quickly outlawed. Cars with fan systems cornered too hard. They were too fast, too difficult to regulate, and they left traditional cars in the dust. So for decades, the idea was abandoned. McMurtry brought it back, but with better tools and fewer restrictions, because they are not part of a racing series. They are not governed by committees. They are an independent engineering company with one goal: build the most extreme performance vehicle ever conceived. And now they have done it. This brings us to a final twist. Traditional combustion cars, like Formula One vehicles, cannot run upside down even if they have enough downforce. Their engines would starve of oil. Gravity pulls engine fluids away from vital components when inverted, causing catastrophic failure within seconds. That is why, even if an F1 car could generate enough grip, it still could not function upside down for long. Electric cars, however, do not face this problem. There is no oil circulation needed in the same way. The motors operate just as well inverted as they do upright, which is why the Spéirling was the perfect candidate to turn theory into reality. It is not just the first car to drive upside down. It is the only one that ever could. And now that McMurtry has proven what is possible, the world is watching. Engineers are taking notes. Manufacturers are scrambling to understand how a company most people had never heard of just leapfrogged every legacy brand in the industry. But if you think driving upside down was the boldest thing McMurtry could do, you haven't seen what happens next. Because in the next one, we're heading inside the rig where the laws of gravity were broken in real time, and the footage is almost too surreal to believe. The inversion test. Behind the stunt that changed everything. For most car companies, a promotional video means rolling shots, slow-motion cornering, maybe a drone or two capturing exhaust notes as the car kisses apexes. For McMurtry, a promotional video meant building a custom steel rig, flipping the car upside down and driving it across the ceiling. And they did not just film it to show off, they filmed it to prove a point. The point was simple. No more talk, no more theories, no more headlines that say, maybe. McMurtry was going to demonstrate, on camera, that their car could do what no other vehicle had even attempted. And that meant building a machine that could simulate the impossible. The platform itself was not a tunnel, because there is no tunnel long enough, wide enough, or structurally sound enough to safely test an inverted driving run at speed. So instead, McMurtry engineered a rotating metal road deck, a short purpose-built structure that would first lie flat, then tilt upward, and finally rotate until it was completely inverted, with the car clamped to it by nothing but fan-generated downforce. It was built at McMurtry headquarters in the United Kingdom, quietly, carefully, no media circus, no racing event, just raw testing behind closed doors. And then, on a seemingly normal day, company co-founder and test driver Thomas Yates got behind the wheel. No crowd, no theatrics, just him and the machine he helped create. The footage begins with the Spéirling slowly climbing a small ramp onto the steel platform. It pauses, perfectly still. Then Yates activates the downforce system. Inside the car, twin fans spin up to over 23,000 revolutions per minute. The suction begins. You cannot see the air being pulled away beneath the car, but you can hear the shift in tone. The Spéirling stops sounding like a car. It starts sounding like a turbine, preparing for takeoff. Then, with no cables, no harnesses, no support beams, the platform begins to rotate. Slowly, deliberately, inching the car past vertical. First it climbs to a 50-degree incline, then 70, then 90. The car is sideways now, still holding, no sliding, no shifting, then 110 degrees, 130, 180, fully upside down, and the car stays put. It does not sag, it does not fall, the tires do not even flex. The The downforce is so immediate, so complete, that the weight of the vehicle becomes irrelevant. In that moment, gravity is outmatched. The McMurtry Spéirling is no longer subject to the Earth in the way other cars are. It is locked in place by a man-made force stronger than the one we are all born into. But the test is not over. Yates does not just sit there and wait for the rotation to end. Once the rig is locked in its inverted position, he gently taps the accelerator. The car moves. Upside down. It rolls forward, unsupported, with the same fluid motion it would have on a normal road. The wheels turn. The motors hum. The fans maintain grip. It is surreal. The entire scene looks fake, like CGI, but it is not. The McMurtry team says it best. Once fully inverted, Thomas drove forward, entirely unsupported. It only lasted a few seconds, maybe 6 feet of travel, but those 6 feet changed everything. Because in those few moments, McMurtry did what Formula One has only ever joked about, what engineers have drawn on whiteboards for decades, what fans have whispered about for years. They drove upside down, and they did it without stunts, without ramps, without editing. The video is short, brutally short, but that is what makes it powerful. It is not trying to sell a fantasy, it is documenting a reality. McMurtry later released statements acknowledging that the rig was a proof of concept. They are not claiming to have built the first car capable of racing along a ceiling for a mile. They are saying they built the first car that can do it at all. And then they showed us. And that honesty only makes it more impressive. Thomas Yates described the experience with British understatement, calling it a fantastic day in the office. But anyone who watches the footage knows that is not what it was. It was a historical moment in engineering, a confirmation that the principles behind downforce on demand are not just clever ideas. They are real, they are practical, and they are scalable. This test also silenced the skeptics. For years, fan-assisted downforce systems have been dismissed as gimmicks or theoretical edge cases. Critics said they would never work in the real world, that they were too complicated, too unstable, too hard to control. But McMurtry proved otherwise. Their system works in the harshest condition possible, upside down, with no assistance, no airflow, no speed, just suction. Controlled, precise, deliberate suction that replaces the need for gravity altogether. And it opens doors. Because if a car can drive upside down, even for a few seconds, it means a whole new range of vehicle designs becomes possible. Tunnels could be reimagined, wall tracks, ceiling sections, emergency vehicles that can drive in vertical environments, space-bound rovers that operate in extreme orientations. It may sound ridiculous now, but 20 years ago, so did the idea of an electric car breaking every lap record in the world. McMurtry's demonstration is not just about shock value. It is about opening a new chapter in what we think performance cars can be. This is not a car built for public roads. It is a car built to challenge everything we think we know about motion, friction, and control. Even the materials used on the rig had to be custom engineered. The surface needed just the right amount of grip, not too much to interfere with the tires, not too little to risk sliding. The rotational mechanism had to account for precise balance. The fan output had to be sustained perfectly, even as gravity reversed direction. The math behind it is staggering. The risk was enormous, but the execution was flawless. And that brings us to the final question. What happens now? McMurtry built the first upside-down car. They filmed it. They proved it. But are they done? Or is this just the beginning? Tunnels, moonshots, and the future of McMurtry. When Thomas Yates stepped out of the Spéirling after the upside-down test, the world did not instantly change. There were no fireworks, no breaking news alerts, no sudden flood of manufacturers announcing a fan-assisted revolution. But quietly, behind the walls of motorsport development centers and aerospace laboratories, something had shifted. Because what McMurtry proved was not just about spectacle, it was about proof. The car did not slide. It did not glitch. It did not crack under the weight of its own ambition. It moved upside down because the physics allowed it to. and McMurtry built a machine precise enough to navigate that physics. That changes things. Thomas Yates hinted that the demonstration was just a beginning, that with a longer track or a tunnel, more inverted distance could be covered. It sounded like a playful quote, maybe even a little tongue-in-cheek, but that one sentence hit like a seed planted in fertile soil. The idea is now out there. So what comes next? The first logical step is scale. The rig used in the video was small, just big enough to allow a few feet of inverted travel. But imagine what happens when you build a larger one. Not just a steel platform, but a full loop. Not just a rig that flips the car upside down, but one that keeps it upside down while it accelerates, turns, and exits the maneuver at speed. That may sound like science fiction. Until you remember that, so did an electric car outpacing Formula 1 lap records. So did a vacuum system that could hold a 1,000-kilogram hypercar to the ceiling without cables. The impossible is no longer theoretical. McMurtry has broken the ice. There is already talk of a longer rig, something that can rotate further and hold steady longer. The dream is obvious. A tunnel, one designed specifically to let the Spéirling or its successor drive a full inverted loop. Maybe 100 meters, maybe a full circle, maybe more. And with McMurtry's team already in possession of some of the most radical aerodynamics in the world, the only limit is material, budget, and time. It will not happen overnight. But make no mistake, this is not the end of the story. It is just the first chapter of a brand new physics experiment unfolding in real time. But the applications go far beyond tunnels. Racetrack design could change. For over a century, track builders have had to consider gravity as a universal constant. Hairpins, cambered turns, and banking are all designed with grip in mind. But what happens when you no longer need gravity to generate that grip? What if you could use vacuum pressure to anchor a car to any surface, regardless of orientation? Suddenly, vertical tracks are no longer out of the question. Spirals, wall rides, enclosed circuits that loop like roller coasters. It sounds absurd.
It is just remarkable watching it heading up the hill.
But engineers do not laugh when they see the Spéirling. They lean in, they ask questions, because the core idea is now proven. Then there is the production side. McMurtry has already announced plans for a limited run of the Spéirling Pure. Only 100 units, all track ready, all capable of downforce on demand. If those cars reach private owners, the data they return could help scale this technology faster than any racing series ever could. We are not talking about theoretical cars here. We are talking about real machines with real owners testing them on real circuits. The feedback loop becomes exponential. Performance improves. Components evolve. And within a few years, you could have a track-legal electric hypercar capable of inverted stunts, 0 to 60 launches under 2 seconds, and lap times that challenge physics textbooks. But let us take it a step further. The fan-assisted downforce system does not need airspeed to work. It can function at rest, at low speeds, or in enclosed environments. That makes it incredibly useful, not just for racing, but for aerospace. Imagine a future Mars rover that needs to cling to the walls of craters or navigate loose terrain where wheels alone are not enough. A fan-based system could provide localized ground suction, allowing the vehicle to maintain stability even in reduced gravity. McMurtry may have built the Spéirling for the track, but the science behind it is portable. You could also imagine utility vehicles operating in extreme environments, underwater, in zero-gravity simulation labs, or on the moon, where gravitational pull is weaker and traditional traction is unreliable. McMurtry has created a proof of concept that demonstrates how artificial ground force can be generated without reliance on Earth's natural pull. That has consequences no one expected. Then there is the racing world itself. If a private engineering group can build a car that sticks to walls and breaks lap records, how long before the established giants take notice? Formula 1 may have banned fan systems, but that was before electric drivetrains became the future, before sustainability shifted the priorities of every major motorsport. If fan-driven downforce can be made quieter, cleaner, and more energy efficient than traditional wing-based designs. It is only a matter of time before someone reintroduces the idea on a major racing platform. It may not be next year, but it is coming. Even manufacturers that rely on traditional combustion engines are quietly watching, because the concept of controlling grip with precision at zero speed opens up new possibilities for every vehicle that needs stability in unpredictable conditions. Emergency vehicles, search and rescue units, military transports, agricultural machines on steep terrain. When a car can cling to a slope at any angle without sliding, that is more than racing tech. That is utility. Of course, this is all just the beginning. Right now, the McMurtry Spéirling is a symbol, a strange, whisper-quiet machine that punches far above its weight. But if the company continues to scale, if the Pure goes into production, and if the rig expands into a full test tunnel, the legend will only grow. They have already proven they can defy gravity. The next question is what else they can break. Lap records? Already done. World first upside-down drive? Checked. Now we are watching a company that is no longer chasing the industry. It is dragging the industry with it. There is a reason McMurtry is not being laughed off. Because even though the Spéirling looks like something from a racing game, even though it sounds like a vacuum cleaner gone mad, the engineering underneath it is deadly serious. This was never about headlines. It was about progress. From racing to aerospace. When McMurtry drove the Spéirling upside down, it was not just a gimmick or a publicity stunt, it was a warning shot, a signal to engineers, designers, and visionaries across every field that something fundamental had changed. Because once you prove that downforce can override gravity, the implications do not stay confined to racetracks. The most obvious impact is on motorsports. Up until now, downforce has been a byproduct of speed. Wings, diffusers, and body shapes all depended on airflow. But McMurtry flipped that principle upside down. Literally, the Spéirling's fans generate thousands of pounds of suction at the push of a button, regardless of velocity. That means cars no longer have to wait to go fast before they can grip. They can grip first, then launch. That alone changes how cars are built. Lighter frames, shorter braking zones, tighter tracks. It means future electric race cars could be more agile than anything built before, simply because they do not need wind to work. The moment the fans spin up, the grip is there. Total control, even while stationary, opens up a world of new track possibilities. Vertical climbs, spiral loops, maybe even full gravity-defying circuits. But the ripples go far beyond racing. The same vacuum principle that holds the Spéirling to a platform could hold a lunar rover to a crater wall. It could stabilize a Mars drone against shifting rock faces. It could allow transport vehicles to maneuver inside zero-gravity labs without needing anchors or magnetic rails. When downforce becomes portable and self-generated, it becomes more than a racing advantage. It becomes a tool for exploration. This changes design theory. Vehicles that operate in unpredictable terrain no longer need to rely on traction alone. Think of mining machines working on cliff faces, or firefighting robots clinging to tunnel walls during search operations. Any vehicle that can use suction to create stability becomes viable in environments where wheels alone would fail. We are not just talking about performance, we are talking about safety, survivability, and access. Even consumer vehicles could be influenced, not with full-blown fan systems perhaps, but with adaptive grip modules. Systems that give extra suction in icy conditions or allow emergency stops with greater control. It is only a matter of time before someone scales the tech down into something street legal. And let us not forget the philosophical impact. For years, engineers have worked around gravity. McMurtry just proved you can challenge it directly. That mindset shift may be the biggest innovation of all. Instead of asking how to reduce drag or increase traction, designers can now ask, what if the car decides where gravity goes? We are entering an era where performance is no longer defined by limitations, but by how far you are willing to push the envelope. McMurtry pushed it, then drove over it, then hung from it. It started with a short test on a metal rig. It might end with a completely new class of vehicles. Because if a car can drive upside down, What else can it do? What started as a myth is now a milestone. The McMurtry Spéirling did what no car has ever done. It turned a joke about downforce into a proof of concept that shocked the world. And it is only getting started. If this story blew your mind, share it. Subscribe. Drop a comment and tell us what you think McMurtry should do next. Loop the loop? Drive across a tunnel ceiling? Take it to the moon? Because this is not just a car anymore. This is gravity, rewritten,